Namaste. I'm trying to explain the estimate of a fall, a 60 centimeter fall from BN Dutta textbook for estimating and costing. It's on page number 439. So we can see here is the half top plan of the fall. It has its longitudinal section over here. Longitudinal section is the section which we obtain when we cut the structure right at the longitudinally, that means along the length. And here we have the section on ABC. If we cut this plan at A, over here B, B and C, we will get this section. This is the longitudinal section. It has upstream full supply level and downstream full supply level. Because it's a 60 centimeter fall, the difference between upstream full supply level and downstream full supply level is 60. There is a fall of 60 centimeter, and the depth of water is 90 centimeter, and the longitudinal slope at different portion is given here. So the important things to note here is the floor area. We've got to calculate the earthwork in excavation for the floor area, then the wing walls are these, and then for the pitchings on these portions, these are brick pitchings, sort of soling, and we have cotton wall over here. Because this is half top plan, we only have half of the portion seen and half of the portion underground seen, and the remaining half shows the above the ground surface. So for the calculation of earthwork in excavation, we assume the upstream bed level as the level of ground, as a ground level. So here we can see the thickness of concrete varies as we move along the length. For a length of 2.65 meter, all the dimensions are given in centimeter, 265 centimeter. The thickness of concrete is 45. So the depth of excavation would be more in this portion than other portions to follow. So let's begin. We have 60 centimeter fall, 90 centimeter water depth. Earthwork in excavation for floor. Let's begin with floor. By floor I mean these portions, these portions. So let's calculate the length. The length at these portions is equal to because the depth concrete varies for different length, I am taking the corresponding length. So for 2.65 meter length, the width of earthwork would be 450 plus 60 plus this much of distance on the both side. That means 450 plus 60, because we have the same thing over here because it's a half plan, we don't see it here. 450 plus 60 plus this small portion. What's the dimension of this small portion? It is this 70 minus 40 divided by 2 on both sides, one side, two side, that gives this to be 15. So 450 plus 2 times 60 plus 2 times 15 gives the width for 2.65 meter length. So this is my length, this is my total length, and this is my breadth. So breadth would be 4.5 plus twice 0.6 and 0.15, twice 0.6, 0.15. This much is 0.15. 70 minus 40, 30. 30 divided by 2, 15. This is equal to here. Now for the depth, as I said earlier, the depth has been calculated from upstream bed level. This is the ground level. So from here to here, it would be 60 plus 10 centimeter brick pitching 70 centimeter plus 45 would give 0.6 meter, 0.1 meter, 0.45 meter would give 1.15. That's for 2.65 flow. Then after that comes the other length, 2.65, 2.1. For 2.1 length, the only thing that would vary is, instead of 60 centimeter width, the width reduces to 50. That's all. So I'll just have the 60 changed to 50. That is 4.5 plus twice 50 plus twice 0.15. 4.5 twice 50 twice 0.15. Then comes the depth. At depth, the depth for 210 would be 60 plus 10 plus 35. That is 60 plus 10 plus 35. So this one's clear also. After that, for the third length, similarly for the third, for 150 meter length, 1.5 meter length, we have width reduced to 40, and corresponding depth reduced to 25. 60, 10 and here 25. That gives us the orthogonal excavation for these portions, 2.65 from here all the way on the other side. The thing that need to be noted is, we have calculated orthogonal excavation for this portion also, is 10 centimeter coping, which need to be deducted at last. We'll do that later on. So now let's move on to wing wall. As we move on to wing wall, after completion of floor, we did these ones of portions. For wing wall, the length is clear, 1.8. length is clear. Length, because we have two wing walls, number is equal to 1, and on the other side, and length is equal to 1.8, width is equal to 70, length 1.8, because it's 2, total length would be 2 into 1.8, 3.6, width is equal to 0.7. Then for depth, we can see here the section of wing wall, it's given here, but we don't know how high is the ground level from the top of concrete. To determine that, we follow from here. We know that top of concrete for wing wall and the remaining portion is same. So from here, when we've got to come 60 plus 10 plus 30. That means from here we can see the ground level is 60 plus 10, 70 centimeter high from the top of concrete. That is, from here also it is 70 centimeter high. So 70 centimeter plus 30 centimeter would be 1 meter. That's the height of excavation, or depth of excavation for wing wall. That is 1 meter. After wing wall, we come to cotton wall. The length of cotton wall is simply given here, 4.5 meter, clearly given, 4.5. There is only one cotton wall, number 1. So, and for the width, we've got to see here, it's 60, clearly seen, we can see that clearly, 0.6. Now for the depth, in the same way, the way we calculated for wing wall, the depth of excavation is from this portion to this portion. So let's calculate from here, 20 plus 5, 25, plus this 20 plus 5, 25, plus this 25 makes it 50, 50 plus 10, 60, 60 plus this 60, 120. So for cotton wall, the height is 120. After cotton wall, we come to brick pitching. We have completed wing wall, we have completed this much of portion orthogonal excavation. Now we come for brick pitching. Brick pitching, as we can see here, these are brick pitchings. So we have two type of brick pitching. One is the horizontal ones, these on the bed, and other the sloping brick pitchings at the side of the canal trapezoidal portion or whatever. So the slope is given 1.5 is to 1. Let's so we can from here to here it's horizontal brick pitching, and this is the sloping portion. This is the sloping portion. As we can see, from here it comes all the way to here. So this is the sloping portion and this is the horizontal brick pitching. We have this portion on the both sides from here and here. So what I can do is calculate this brick pitching with length 1.8 or whatever, or 3.6, you can vice versa that. I'll take 1.8 length, width 3.6, and for 20 centimeter brick pitching depth is 0.2. For upstream brick pitching 1.8, 3.6, 20 centimeter brick pitching. This completes this portion. Now for the sloping portion, I have length 1.8 fixed, not changed, 1.8, because it's on the both side the number is equal to 2. And now for the width, we have, for width we need to calculate the hypotenuse length, that is this length. We have this height is equal to 90 centimeter from here. So if this is 90, from Pythagoras theorem we can determine, if this is 90 and this is the slope, we can actually determine that by unitary method or simply by Pythagoras theorem, that this length would be root under 1.5 square plus 1 square times 0.9. So that length turns out to be 0.9 square root of 1.5 square plus 1 square, 1.622. And the depth of brick pitching is still 0.2 meter. I wrote that there. So we completed upstream 20 centimeter brick pitching. Now comes the trapezoidal portion here, over here, this portion. For this we can do that in two ways. One is by considering these 20 centimeter brick pitching all the way, or doing that separately. It's easy, it's wiser, it's better to do it separately, because we don't have pitching below the toe wall, we have pitchings only in between toe walls. So I'll calculate the earthwork in excavation for the trapezoidal portion here, this portion over here, including the toe wall portion, and then later on again calculate for 20 centimeter brick pitching. So first comes the trapezoidal portion brick pitching. Here we can see, for the trapezoidal portion we know the formula for calculation of volume is equal to BD plus ST square times length. So first we need to determine the breadth, depth, side. We know side slope is equal to 1.5 here, and length. So let's go with breadth. For breadth is the average breadth, because for this portion here it is 4.5 and here it is 3.6. we will take the average depth, that is average of 4.5 and 3.6. that's pretty clear. And the length, now length is equal to 4.2 minus, because we have already calculated the earthwork for this portion, we need to deduct that one. So as we can see here, 4.2 is from here to here, and this total is 60, this is 30, that means this is 15 and this is 15. So the earthwork in excavation for trapezoidal portion would be, from the length would be from here to here, that is 4.2 minus 30 minus 15. That is what I did here. Length is equal to 4.2 minus 30 minus 15. That gives me the length is equal to 3.75. Again, it has a varying depth at two portion, because we aren't considering for 20 centimeter brick pitching, we are doing it without brick pitching. The depth of excavation here is 60, and the depth of excavation here would be 60 plus this distance, that is this distance comes from the slope 1 in 10. For every 10 meter length it has depth of 1 meter. So we just determined the length at that portion is equal to 3.75 meter. From here to here it is 3.75 meter. So for this distance the depth would be 0.37. pretty clear, that's pretty clear from the slope. So depth would be 0.37, this much would be 0.37, but because it's plus 60 we have added 60. Or instead we could also just do 4.2 minus 30, because the slope begins from here. Actually the slope begins from here, so instead of deducting more 15 we could just do 4.2 minus 30 and then apply the slope. That gives us here 4.2 plus, for a length of 4.2 minus 30, that's 3.9. it gives 39. So depth turns out to be 0.8. Why did we do 0.39? Because we know the distance from this portion to this portion is 4.2 minus 30, that is 39. For 3.9 meter with slope 1 is to 10, the depth would be 0.39. hence we did 0.39, and 0.39 plus 60 would give 0.99. So the depth is equal to 0.8. the depth is 0.8. so we will put here the depth is equal to 0.8. length is clear. We are doing here over here trapezoidal portion. So breadth is clear, length is clear, and depth up to 60. Depth at this portion 60 clear. Depth at this portion 60 plus 39, 99 clear. Now the average depth at upstream and depth at downstream, average depth would be 0.8. So I put everything on the formula, that's B times D plus SD square times L, that is B times D plus SD square times L gives this value. That's clear, pretty clear I guess. Now after trapezoidal portion we go to brick pitching. Brick pitching is at this portion. Brick pitching is at this portion, that is 20 centimeter brick pitching. Now as we found for earthwork in excavation, the length is equal to 3.75. that is the length from this portion to here. So for brick pitching again the length remains the same, 3.75. and for width again, now we calculated for the trapezoidal portion, this major portion we did without brick pitching. Now we are doing brick pitching, but we know brick pitching there is no brick pitching below the toe wall. There is brick pitching only in between the toe walls. So to take the breadth we need to take the average distance between this portion and this portion, that is 4.5 minus width of toe walls on the both sides, that is 4.5 minus 20 centimeter wide, 20 centimeter wide on the other side, that is 40. 4.5 minus 40, 4.5 minus 40 is 4.1, and here similarly 3.6 minus 0.4 is 3.2. So that is what my average width is. And for the brick pitching of 20 centimeter, depth is 20 centimeter. So with this I completed brick pitching at this portion. Now the remaining brick pitching is at this portion. Here we can see, because it's on the both side here and on the other side also, the number is 2. Length, for length we can see that the length is 4.2 here, and here it is reduced to 2 meter. Here we can see from here. So we need to take the average length to calculate the pitching here, because it's reducing, so we take it average, that is average of 4.2 and 2, which gives average of 4.2 and 2 3.1, because it's on both sides, multiplied by 2. Now for the depth, in the same way for as we calculated for this, we'll calculate the depth. As we have found that depth turned out to be 0.8, that is vertical depth at this portion, but we need to convert that to slant depth. That's it at a slope 1.5:1. We'll again apply the same rule, that's 0.8 root under 1.5 square plus 1 square. 0.8 is the depth at this portion, we calculated it, vertical depth. How did we know that? We took the average of this and this. Here it is 60, here it is 60 plus almost 40, 100, and average is 80, and that's the vertical depth. But we need a slant depth, so we are making it slant with the slope 1.5:1 over here. For 20 centimeter brick pitching, the depth is still 20. So we are done with downstream brick pitching. That's all. Now the remaining portion is for the curved portion. Here for the curved portion, this curved portion goes all the way here, all the way to here. So it has its radius 60. It is on the both side, so we'll put 2 in front, and for circle we know the area is equal to pi r square. It gives us this, and because it's brick pitching, again we are taking it, we are multiplying by the depth is again 20 centimeter, that's 20 over here. Now for toe wall, we calculated orthogonal excavation for trapezoidal portion over here, and for that that means we calculated over here, we calculated the quantity for this portion, but we haven't gone 30 centimeter deep. That means we haven't done for toe wall. So for toe wall, the length again is length from here to here, as we calculated here, is the same 3.7, because it's on the both sides 2. There are 2 toe walls, 1 toe wall, 2 toe wall, and for the toe wall the width is 20 and the depth is 30 as given in the question. So this is the quantity, there is no much hassle. 20 centimeter deep, 30 centimeter deep, 20 centimeter wide, 30 centimeter deep. So the quantity for toe wall is clear. Now as we had done for 2.65 turns out to be from here till here. So there is no excavation at this portion, so we need to deduct that one. That's the deduction for what we did at 2.65. so the length, how long is the deduction is the length for deduction would be 60, or you could take 10 as length and 60 as width, as you wish, because 60 is the longer length. I'll take 60 as length. So we have the same thing on the other side also, so -2, and length is equal to 60, width is equal to 0.1, and depth would be the same as we took for 2.65. so length 0.6, depth width 0.1, depth same as that we took for 2.65. This completes the deduction, and this is the earthworking excavation for it.